Okay, folks, gonna teach you about the mass balance equation, and this is about it gives you the mathematical tools to solve some problems regarding concentration of pollutants in waters that are mixing. And in this picture, you can see, I think it's the Ohio River. And by the way, I forgot to credit here. I think it's kids.britannica.com, something like that. I just grabbed it from them. Anyway, I think it's a picture of the Ohio River and a tributary to the Ohio River. And you can see that this river here, a tributary, has got some turbidity to it, and it's mixing with this. And so it symbolizes what we're doing. It could be any, the pollutant of interest could be anything that meets the assumptions of the mass balance equation. And before I talk about those assumptions, I just wanted to say why we're doing this. Well, this week we are learning some domain knowledge about eutrophication and water chemistry. And also in lab this week, you will be beginning to learn about Excel. And so this is our first Excel lab, and we need something to work on, and so we've got this mass balance equation. And so the problem you'll be working on this week in lab will be a mass balance equation, and I just want to just demonstrate to you what that's about. Okay, so it's the mixing of waters and the pollutants therein, and figuring out both the amount of water, the mathematical tools to figure out the amount of water upstream, downstream, and from the tributary, as well as the concentration of pollutants upstream, downstream, and in the tributary. So first of all, the assumptions of the basic mass balance equation are as follows. First, that the substance that you're considering mixes completely. Not true in this case. You can see that this turbidity does not mix completely. And I've seen cases, for instance, I flew out of the Arcata airport once, and or I don't know where I was flying from, but we crossed the mouth of the Klamath River, and the Klamath River was turbid and it went into the ocean, and for many, many miles it did not mix. Okay, so that happens. Anyway, the assumptions of the formula in nature probably aren't frequently met. There are modifications of the formula that you would learn if you were an environmental engineer, but you are not, and so we're just doing the very basic thing. All right, so first, substances mix completely. Second, the substance is not otherwise added to or subtracted from. So, for instance, there is no chemical reaction when the water, at any point. So if they give you a concentration of some compound, that is not going to be lost through chemical reaction, nor by, for instance, evaporation or precipitation. It doesn't precipitate out. So the stuff just stays in the water and mixes. And then there, of course, to me, there is no change in water volume other than that given in the problem. So, for instance, there's no additional groundwater infiltration or exfiltration. The water stays in the streams. There are no other tributaries adding to the volumes, and there's no evaporation. And lastly, I just have to say it, the measurements are accurate. Measurements are never entirely accurate. There is always uncertainty in measurements, and so it is wrong to assume that measurements are accurate, which means that paying proper attention to significant figures is an important part of this, as you should already know. All right, let's dig into it. So I'm going to do this a little strangely because I don't have a touch pen, so I made this diagram. I'm just going to set you up for A, doing the lab this week, and B, solving these problems when I give them to you on quizzes or exams. And there'll always be a problem that says there's a river and it has so much water in it, and it's got a concentration of something that is this value. And it meets a tributary or a factory or something like that that is discharging this much water with a certain amount of pollutant in it. What is the volume and the concentration of pollutant downstream? Alternatively, I might say upstream it's this and downstream it's that. What is the stuff here? So the point of this lecture is to give you the tools for answering those problems. So what I'm going to do here is actually do it this way. I'm actually going to draw for you. Let's see. Is that what I'm doing? Hold on. No, I'll do it this way. Okay. So first we need some symbology, and we're going to use the letters Q and C to be consistent with how engineers do this. Q and C. Let Q equals the quantity of water. So I'm going to put Q and C up here. Oh, what I meant to say is I give you these word problems. What I recommend you do is immediately draw it out like this. And I'm going to do this for you, and what I am doing for you, I am modeling what I suggest you do. If you try to do it some other way, good luck, God bless you, but if you do it this way, I think it's going to work. So let Q equals quantity, and just think about the units for a second, because you're going to see them in the problems. The quantity of water, it's going to be a volume over time, like this much water passing over this point per second. So for instance, cubic feet per second. And just visualize what that would look like. Turn on your faucet and you're going to have a Q coming out of the faucet, a volume over time. You could put a gallon jug underneath it and time it, and you'd have 1 gallon per that many seconds, and that would be the Q. And let's let C equals concentration. This is a chemical symbology. What would be the units? Well, it's going to be mass over volume, and the units will change. For instance, I'm giving you 10 micrograms per milliliter, but it could be nanograms per liter, or I don't know, cubic feet, ounces per cubic feet. Okay, mass over volume. This isn't super important, that I'm not sure if this is going to be necessary down the road when you figure out these concentrations. I could be super mean to you and give you a problem that gives you different units, for instance, metric units here and English units here for quantity and concentration, but I ain't going to do that because that would be cruel and unusual. But you should have the tools for doing that because you know the railroad track formula and that kind of problem solving. So I'm just throwing this out at you. So now this is what I'm going to do. Okay, I'm actually going to do this live for you. Here's what I suggest you do, is you draw it out and you put your Q's and C's over here. You've been given a word problem and now you want to solve it. And let's just say you don't automatically know what to do. So you should draw this out. So I'm just going to copy this here and paste it twice. All right, so I'm going to put QC here and QC here, and then number them, okay? This is going to be Q1, C1. Let this always be Q2, C2, and let this always be Q3, C3. Whoops, not 4, 3. Okay, this is the upstream, this is the downstream, this is the tributary. All right, and this is important that you know this, because otherwise later on you're going to be given Q1, Q2, Q3, and you need to know which part of the diagram they're in. Is it upstream, downstream, or is it the tributary? So make sure you're familiar. This is how I do it. You could do it some other way, but this way works. Okay, so again, upstream 1, tributary 2, downstream 3. Now, hopefully it makes intuitive sense to you. We're going to do some solving here. There's two things going to happen. First, I'll just go with me here. Hopefully it makes intuitive sense that Q1 plus Q2 equals Q3. Maybe not, because those numbers just went through your head. So let's explain. What does that mean? The quantity of 1 plus the quantity of 2 equals the quantity of 3, which means the amount of water downstream equals the amount of water upstream plus the amount of water from the tributary. Hopefully that makes intuitive sense. If not, reverse the video, go back and review what I just said. This water plus this water equals that water. However, it is not true that the concentration here plus the concentration here equals the concentration here. I'm not going to take the time to explain why that is, but if you substitute some imaginary values and make this like the Mississippi River, and this a tiny trickle, and this a low concentration, and this a high concentration, you'll get an absurd answer if you make that assumption that C1 plus C2 equals C3. So this bit is important to solving mass balance problems, which I think we come up. Okay, it'll come up in a second, you'll see. So memorize these two equations. First, Q1 plus Q2 equals Q3, what I just said. It should make intuitive sense that that's true. You might not even have to memorize it if you just remember that. Remember not the equation, but the concept. The second one is the hard one. This is the mass balance equation. This is it. And you need to memorize it, and you need to be able to work with it algebraically. So Q1 times C1 plus Q2 times C2 equals Q3 times C3. Okay, which means if you multiply these two and add it to the product of these two, that equals the product of these two. That's not intuitive, at least not to me. And how was that figured out? I don't know. Probably people who know calculus. But it doesn't matter because this is all we need to know. Now, in problem solving, typically you're going to be given two Q values and two C values. What do I mean by that? I'll give you this one and two C values. So you're going to be missing two other values of the six that are here. And so what do? Well, I'm going to give you some advice. First of all, it's easy to solve for the third Q value. So if I give you any two of these Q's, you should be able to solve for the third. I won't insult you by asking you to figure out how to do it. I assume you can do that. However, once you solve the second Q value, you're going to be missing one of the C values here, but you know all five things here, five of the six, and you only need one more. So you need to use algebra at first to isolate the unknown C value and then plug in the known numbers and solve it. Okay, so the first step is get all the Q's. The second step is to solve for the unknown C wherever it is using algebra. And then the third step is to sub in all the values, do the math, and figure out your answer. And lastly, don't forget to address significant figures and scientific notation. I can't tell you how many students who've done everything perfectly lose a few points at the end because they don't stop and do everything thoroughly. And to do a thorough answer on these problems is to express in sig figs and scientific notation, which is the default expectation in this class. Okay. So, I'll just do some algebra review for you in case you've forgotten how to solve for any of these things, and skip ahead if you already know this stuff, or just follow along. So let's just say we want to solve for this guy right here, C2. Okay, so what I'm going to do, I'm actually going to just copy this guy here, and then can I just paste it? It's small. Can I paste it? Yeah, okay. Okay, so if I want C2, I need to get rid of everything by C2. And order of operations is that if there's addition or subtraction, you take care of that first, and then you take care of the multiplication. So I'm going to have to subtract this thing out. So I need to move this to the other side. And I need to get rid of the plus sign. I don't need that anymore. I'm subtracting it from here, so I simply go minus that. Okay. And so what am I looking for? C2. There's my C2. That means I need to divide both sides by Q2. And I'm going to do that it's actually a two-step operation. First you set up and then you solve for it. But I'm just going to do that in one step by just moving this guy next door, which I can do. So copy this. Actually, hold on. Oh no, okay. Okay, what am I doing? I'm moving the Q2 over, so let's get out of here. I don't need the parentheses anymore. And actually, I do have to be very careful how I put parentheses in over here because I want to do everything on top because there's some addition or subtraction there. So let's make this thing 1, and then I'm just going to write backslash Q2. Q2. Okay, and I'm done. I've isolated C2. Now, ladies and gentlemen, this is great. Solve it and then do sig figs and scientific notation. This looks a little bit, messy, right? Well, yeah, it's a mathematical expression. It's not a simple one. In Excel, by the end of lab this week, you need to be able to express this equation here in Excel. And I'm going to explain how to do that, well, hopefully, in the next video, which is a real primer on how to start Excel. But if you think about it, you're simply, if you think about it, what you're doing is you're saying some cell equals some things that are multiplied and subtracted and divided by, and they're organized according to parentheses. So that's what you'll be able to do in Excel soon. Okay, I won't go into it now. So what I will do, though, is give you a sample problem. Let's do this together. So river, and this is kind of the form of the questions you might get on an exam. Given that the exams and quizzes are timed, I would make them as simple. I would make them pretty simple. Hopefully I would give you enough time. But really, if time is a problem for you on these things, make sure you practice these problems so you get good at them so you can do them quickly. Okay, a river has a concentration of mercury of 11 micrograms per cubic liter. Concentration, there's that C. Oh, and a flow rate of 155 CFS. You don't really have to know what CFS stands for. It's a unit, and its flow rate. You do have to recognize that this is a Q, a quantity. So let's just actually write this down. Let me do it this way. So let's see. No, I'm not going to write it down yet because I need to know whether there's C1s or C2s or stuff. So let's draw it out. Dupe. Uh-oh. And sorry, this is weird. Okay. And then could do doop. And another one. Shoot. Okay, there's my standard river. And so what's my Q's and C's? I put in some text boxes here. Q, C. And you know what? I'm going to need this 3 times, so I'll just copy this. Control V, and Control V, and move them over here. Sorry, I can't help but talk to myself when I do this. So this is going to be 1, and this is exactly what you might do with a pencil. This is 3 down here. It's a lot faster with a pencil. No, 4. Very funny. 2. Okay. All right. So let's see. A river, and this is the upstream river. This is 1, and it has an initial concentration. And after a while, it's going to ask what's going on downstream. So Q1 equals quantity 11. I'm not going to put in the units here. Concentration. Uh-oh, I did it wrong. Okay, concentration is 11. Flow is 155. And then they're going to talk about the tributary next. It discharges water at a Q of 12 and a concentration of 137. And 3 doesn't tell you anything at all. So what did I say? The first thing to do, find out Q. So Q is going to be 155 plus 12. I should write it down just in case I do a mistake. I can backtrack and find my mistake, but I'm going to do this in my head. I think it's 167. 167. And I'm going to bet that they ask what C3 is, the concentration downstream. What is the flow rate and mercury concentration downstream? Yes. Okay, so I need to set up the mass balance equation. Can I just grab it from somewhere? Sure, except I'm going to do it this way. All right, I actually can't because I got to solve for Q3. Okay, so I'm copying that. Oops. Oh, look at me. On my last slide, I actually had everything already here. Okay, so let's do this. I'm going to bring this over, and I need C3, right? Right? I need C3. That is correct. So let's solve for C3. Oh, super easy. All I got to do is divide both sides by Q3. Okay, I can do that. I need Q3 on the other side. So I'm going to subtract it. No, I'm going to divide it. Make sure I put my parentheses in here. And a backslash Q3. So I think I already have Q1, C1, Q2, C2, and Q3 from the other slide. And I do. I've got everything except for C3. So I'm not going to waste your time by plugging in the numbers and doing the calculation and then adjusting for scientific notation. I will say one thing about sig figs, though. I just wanted to make sure you guys could do the algebra and could figure out any of these symbols. Okay, so multiple students are still struggling with significant figures. The rule is you go back to the numbers you've been given, figure out which ones are measurements, and look for the ones with the smallest number of digits in them. And we are given 11 micrograms per cubic liter. Is that a measurement? Heck yes. It's not a count. No one can see individual bits of mercury in micrograms. Somebody must have measured that. A flow rate of 155. Somebody must have measured how much water is going through a river. And by the way, that is not an easy calculation to do. And the same with the rest of it. That's a flow rate, and that's also a concentration. It's all measurements. There are going to be two significant figures in your answer because the smallest number of digits in this group of numbers is two digits. So after I do my math, I've got to adjust to two significant figures and then express it in scientific notation unless Murphy has said otherwise. Okay? That's all. My next lecture will be on how to use Excel. All right, good luck. Have fun this week, and getting this equation into Excel is going to be one of your major challenges. If you really struggle with that, you know what to do. Ask for help. We got your back. Okay, bye-bye.